Hello and welcome to my chemistry lectures. Now, these are going to be like my pre-calc lectures in that I'll be going through material rather quickly. This is meant for a review. If you don't quite understand something, be sure to check out my actual chemistry tutorials, which will better explain chemistry. Now, this says chemistry 2, but this can also be a high school chemistry course. I put a high school AP chemistry course. I put chemistry 2 because those are the kind of topics that we're dealing with. And this is going to deal with exactly half of our materials. We're going to deal with the other half after we finish through these. So I'm going to begin with a review of significant figures, dimensional analysis, naming compounds, and chemical equations, stoichiometry, basic stuff that you learned in Chemistry 1, basic chemistry stuff that you need in order to do all these problems. Next, we're going to begin with aqueous solutions, where we're going to go over electrolytes, predicting aqueous solutions using the solubility rules, and complete neck ion equations, which kind of go hand in hand, acids and bases and neutralization, which are the same exact thing, and then we're going to end off with redox reactions. Then in this third lecture, we're going to go through a little bit more of aqueous solutions, covering such things as the activity series, molarity, the dilutions and titrations, basically just measurements. Next, we're going to go through thermochemistry, which is going to deal with kinetics, enthalpy, and reactions, and then we're going to spend a lot of time with calorimetry, which is basically a lot of numbers, which substitutes the majority of thermochemistry. Next, we're going to deal with electronic structure, and we're going to briefly go into electromagnetic radiation and wave nature and wave particles, a little bit of quantum mechanics, but it won't go too in detail. We're going to stray back and go into quantum numbers and then get electron configuration, and then we're going to go with a little bit of anomalous or unusual electron configurations. Next, we have periodic trends, and the entirety of that lecture is going to be me just describing the three periodic trends: atomic/ionic size, ionization, and electron affinity. Next, we're going to go through chemical bonding, which is going to entail largely just Lewis structures, and dipoles is a very short topic. Now, a little bit of Vesper theory. Vesper theory will be where we get into electron domains and molecular geometries. And I don't know quite yet if we're going to break this lecture off into two lectures. We may to cover hybridization, sigma and pi bonds, as well as bond order, which are molecular just bonding theories. They might not go hand in hand in our lecture, and they might take up too much time, so we'll see what happens. But after we finish with that, we're going to go on to gases, which will deal with the ideal gas equation, and just a bunch of equations, and just really take a look at gases. Shouldn't be too difficult. And then intermolecular forces shouldn't be very much difficulty either. And lastly, we're going to end our lecture with a discussion of solutions. So we're going to begin with talking about what a solution is. You might remember that we would have talked about that a couple lectures earlier, but we're really going to go in and look at more than just aqueous solutions, just solutions all around. We're going to look at the solute-solvent interactions, and we're going to try to figure out colligative properties. That's going to be the majority of our focus when we're going through these. So